first question, what is chimney draught? Second question, solve one problem for the calculation of chimney draught in terms of millimeter of water by manometer and in terms of height of hot gases column. Third question, solve one problem for the condition of maximum discharge through the chimney. Let us first understand what is draught. Fresh air required for combustion will enter in the combustion chamber only when hot gases will be exhausted from the combustion chamber in the boiler. And this is possible only when there is the pressure difference is maintained above and below the fire grate. And this pressure difference is known as draught. We will understand what is the chimney draught. So chimney draught is the natural draught and it is having induced effect. Now why induced effect is occurring in the chimney draught? Because of the density difference in between the hot flue gases and the outside air of the chimney. We will understand the chimney draught with the help of this diagram. Now here is the boiler, for which here is the level of grate. Now on this grate combustion process is taking place and chimney is getting attached. Now if we observe for this chimney, here the manometer is there. Now why manometer is attached? To show the pressure difference, and here this pressure difference is measured with this height h. Now when here the combustion process is taking place, then hot flue gases are getting generated. Now we know that the outside air, that is air outside this chimney, is having higher density. So this higher density air coming inside this combustion chamber and it will push the hot flue gases outside the combustion chamber. Now why it is pushing the hot flue gases outside the combustion chamber through chimney? Because this flue gases is having lower density, and because of this density difference the pressure difference is also getting maintained above and below this level of grate, and that's why this draught or chimney draught is known as the natural draught. Now we will understand some notations. If we observe, here is the height h is shown. So this height h, capital H, is the height of chimney above the fire grate. So this is the level of grate and it is measured in meter. Then small h. So here is the draught required in terms of millimeter of water. So this manometer, in the manometer pressure difference is measured in terms of millimeter of water. Then T1 is the absolute temperature of air outside the chimney and T2 is the absolute temperature of flue gas inside the chimney. And these temperatures T1 and T2 are measured in Kelvin. Then V1 and V2. So V1 and V2 is the volume of outside air at temperature T1 in meter cube per kilogram of fuel for the outside air, and V2 is volume of flue gases inside the chimney at temperature T2 in meter cube per kilogram of flue gas of the fuel. Then M. So some air is required for the combustion process. So M is the mass of air actually used for combustion, and it is in kilogram per kilogram of fuel, and M plus 1 is the mass of flue gases in kilogram per kilogram of fuel. So these are the notations. Now if we observe this diagram, here the column of cool air is given. So this is the column of cool air and that is equal to height of chimney. So this outside air, that is nothing but the air in contact with the outside of the chimney, and this is the column of cool air that we have to take, which is equal to capital H. Now when flue gases are coming out from the chimney, then here also the flue gases, that is the hot gases, are available in this way. So if we take some height above this chimney, then this total height from this level of grate is known as equivalent column of hot air. So this H plus H dash is nothing but equivalent column of hot air. We can express the draught pressure in terms of millimeter of water by manometer as well as the column of the hot flue gas. Now what is the condition for the maximum discharge through chimney? When the temperature of the hot flue gas, that is T2, is slightly greater than the temperature of outside air T1, then this is the condition for the maximum discharge. In the same way, the column of the hot gas producing draught should be equal to height of chimney, that is H dash is equal to H. Then this is also the condition for the maximum discharge through the chimney. Now we will solve one problem for the calculation of draught pressure in terms of millimeter of water as well as in terms of column of the hot gas. I will read what is the given question. In a boiler with chimney of 30 meter height, the flue gases which pass through the chimney are at a temperature of 288 degrees Celsius. Atmospheric temperature is 21 degrees Celsius. Air flow through the combustion chamber is 18 kg per kilogram of fuel burnt. Find first theoretical draught produced in millimeter of water and in height of hot gases column. Second, velocity of flue gas passing through the chimney if 50% of theoretical draught is lost in a friction at the grate and passage. So this was the given question. Let us understand what is the given data. Here height is given 30 meter, that is capital H, this is the height of chimney. Then the temperature T2 is given. So temperature T2 is the temperature of hot flue gas, 288 degrees Celsius. So we have to convert it into Kelvin, that is 561 Kelvin. T1 outside air temperature 21 degrees Celsius, that is 294 Kelvin. And here the mass M is given. So this mass M, that is the mass of air actually required for combustion. So it is 18 kg per kilogram of fuel. Now we will calculate theoretical draught produced in millimeter of water. So this small h, theoretical draught produced in millimeter of water by this manometer, small h is equal to 353 capital H 1 by T1 minus M plus 1 by MT2. So M plus 1 is nothing but the mass of the hot flue gases. So we will put all the values. So values are from the given data. So when we put all the value, we will get 16.1 millimeter of water. So this is the answer of first question. Now we will calculate the theoretical draught produced in the height of hot gas column. So here is the height of hot gas column. So we will calculate here H dash is equal to H in the bracket M divided by M plus 1 into T2 by T1 bracket complete minus 1. So when we put all the data, then we will get the answer 24.2 meter. Now next question is velocity of flue gas passing through chimney. So what is the velocity of flue gas passing through chimney? Now condition is given that the theoretical draught is lost by 50% because of the friction. So friction is occurring in between this inside the chimney and hot flue gas, and that's why there is the draught, there is the theoretical draught in lost, and it is lost by 50%. That means what is the available draught? So available draught is the remaining 50%. So when the draught is lost by 60%, then available draught is 40%. So we have to consider here the net available draught. So available draught is remaining 50%. So we have to take the draught available, that is total draught is 24.2 and lost draught is 50%. So available draught is remaining 50%. So 50%, that means 50 by 100. So we will take here 0.50. So 24.2 multiplied by 0.5, which is equal to 12.1 meter. So this is the draught available. Now we will calculate the velocity. So velocity is equal to 4.43 under root of h dash. So this h dash we have to take the draught available, that is 12.1, and answer is 15.4 meter per second. Now we will solve the problem for the condition of maximum discharge through chimney. I will read what is the given question. Chimney height 60 meter, temperature of atmospheric air is equal to 27 degrees Celsius. If 15 kg of air per kilogram of fuel is used, find the maximum discharge of hot gases. First, the temperature of hot gases and the draught pressure in millimeter of water. So this was the given question. Let us first understand what is the given data. It is given that the height of chimney 60 meter, temperature T1 is given. So T1 is the temperature for this at outside air, 27 degrees Celsius. So we will convert it into Kelvin, that is 300 Kelvin. And the mass of air actually required for the fuel combustion is given, that is 15 kg per kilogram of fuel. So this is the mass of air. So this is the given data. Now we will find out for the condition of maximum discharge what is the temperature of hot gases. So temperature T2 for these hot gases we have to find out. So here is the formula. T2 is equal to 2 in the bracket m plus 1 by m into T1. So 2 m, that is 15 plus 1 by 15 into 300, that is 640 Kelvin. So this temperature of hot flue gases should be equal to 640 Kelvin for the maximum discharge to the chimney. Then draught pressure in millimeter of water. So in millimeter of water, that is in manometer, draught pressure is measured by this H. So we have to write here H is equal to 176.5 into capital H divided by T1. So this capital H is given, T1 is also given. So 176.5 into 60 by 300, that is equal to 35.3 millimeter of water. So this is the answer.